Hello everyone. So today we'll work on the logarithm. We'll discuss some old CAT questions which is based on the past 3 years, and we'll try to brush up the concepts related to logarithm. Now there are few things which you need to keep in mind whenever you are dealing with the logarithm part. So what is logarithm? Basically it's nothing but the representation of the index value, right? In other sense, suppose I have written a value here as log 100 to the base 10 is equal to 2. Here I can say that 10 raised to 2 is nothing but 100. So here this is the index value. I can say log is nothing but the representation of the index value. But moreover, there are a lot of formulas in logarithm. The good part is maximum time your question will be based on the formulas itself, so we can utilize the formulas. But there are some other basic concepts which you need to keep in mind whenever we are dealing with the logarithm part. So here, if I have value as log a to the base b is equal to n, I'll frame these as few terms like n, or the index value here is nothing but time. This is the size, and this is the rate part. In other sense, I can say logarithm is nothing but the time required to reach to a particular size with a specific rate, right? In other sense, I can say with a specific rate at what time I'll be in a particular size. That concept is nothing but the concept of logarithm here. Let's try to analyze this one in terms of a table. So I'll take the value as log to the base 10, right? And here I'll consider a as, let's start with this point at 0. The value of a is nothing but 1. When it's 1, it's 10, 100, 1000, and this process continues. In other sense, I can say at the present label or 0 label or 0th hour, my size is 1, and I am changing my size in such a format so that it will become tenfold of the previous size in the next hour. That's why in the very first hour it will be size as 10, and then again it will be nothing but 100 because it's into 10, then again it's into 10,000, and this process continues here, right? Or else if we'll move in the past, if we'll go 1 hour before, it is supposed to be, as I'm increasing it by tenfold of the value, so it was supposed to be 1 by 10 here, right? Then only I can reach to 1 here, and then previously it was nothing but 1 by 100, right? So this process continues. Now from this thing, there are few things which you can identify here. Can we identify that the value is available here? If the value is log a to the base b is equal to n, I can say n, which is the time frame here, can be positive, can be negative, right? Or else the current scenario after some hours, before some hours. So it can be positive, can be negative. Here if we'll consider my size, the value a, can it be negative? It cannot be negative, right? So here we can see that it's 1 by 10, 1 by 100, 1 by 1000. This process will be there. It will be almost tends to 0, but it will never be equal to 0. So can I say it should be, a value should be greater than or equal to 0. A value has to be greater than or equal to 0 here. My size will always be greater than 0. It can almost be equal to 0, but it cannot be equal to 0. Similarly, b, the rate part here, can we say that the rate part here is always a positive value, right? It's always a positive value here. My rate is always a positive value. And can I say it should not be equal to 1? Because suppose my rate is 1/4 of the previous value, so it will always remain constant. There will be no change in the rate, sorry, in the shape here, in the size here, right? So this is an important part which you need to keep in mind. A lot of questions earlier were used to be based on these three information itself. So let's see the basic brush up. Logarithm of a negative number and 0 is not defined, as we have seen. A value should be greater than or equal to 0. Base of a logarithm cannot be 1, as we have seen. The base of a logarithm is always positive. The base of the logarithm is always positive. It should be greater than 0, right? That's my condition available here. Sorry, one fault here. It should be greater than 0, not greater than or equal to 0. It is tends to 0, so here it should be greater than 0. Right, now some basic formulas which you need to keep in mind. There's a list of formulas which you can go through. Let's not peep on these formulas, or else let's not discuss these formulas. You can always go through some basic example to find out the relations here. One additional formula which you need to keep in mind is, suppose if it's given a raised to log b will always be equal to b raised to log a. With respect to that, I can also say a raised to log p to the base a will always be equal to p, right? So these are some of the basic formulas which you need to keep in mind whenever you're dealing with the logarithm part. So let's move to some questions now. So let's take a question from CAT 2020 slot 3. So here the question says log 30 to the base a is equal to capital A, then log 5 by 3 to the base a is minus b. Remember, it's minus b here. And then log 2 to the base a. I can also represent this one as log log a to the base 2. So I can represent this one as log 2 to the base a, because the previous two values were in the base a. It should be equal to 3. I'll just mark these, and my requirement is nothing but to find out log a to the base 3, right? In other sense, I can also represent this one as 1 by log 3 to the base a, right? So that is my requirement here. Now if I'll go through options, all the values were in terms of a plus b, a plus b, a plus b, a plus b. So ideally I need to work on a plus b. So let's see, if I'll take a plus b, that means it should be nothing but a minus b here, right? So that would be nothing but log 30 to the base a minus log 5 by 3 to the base a. So if we'll work on this, I can say it's a plus b is supposed to be log 30 divided by 5 by 3 to the base a. Let's work on this, right? So could have been written as log 2 into 3 square to the base a, right? So I can say a plus b is supposed to be log 2 to the base a plus twice of log 3 to the base a, right? And my requirement is to find out log a to the base 3, right? So here, if we'll take this part, I know this part is equal to 3, so I'll shift the value towards this side. I can say a plus b minus 3. A plus b minus 3 should be equal to twice of log 3 to the base a, which is also equal to a plus b minus 3 by 2 is equal to log 3 to the base a. So that reflect log a to the base 3 will be a reciprocal of this value, 2 divided by a plus b minus 3. So 2 divided by a plus b minus 3, my answer should be nothing but a in this case, right? So it's basically formula based. The log part is basically formula based. Sometimes you can utilize the options, so you'll have to be slightly careful with the values available. Let's see next one. 2 into 4 into 8 into 16 divide by log 4 to the base 2. That means it's basically, I'll just write down the value so that you can identify. Log 2 square to the base 2, right, whole square. Next value will be nothing but, just identify this thing, it's log 2 cube to the base 2 square here, whole cube. The next one is nothing but log 2 raised to 4 to the base 2 cube raised to 4. Right, so these are the values available. So let's directly write down the values. Here it's 2 into 4 into 8 into 16. Here the value is 2 square, right, which is nothing but 4. Here the value is nothing but 3 by 2 whole cube. So I'll just write 4 as 2 square so that we can work on some relations. And then the next one is nothing but 4 by 3 raised to 4. This is cube, correct. So let's try to solve some values here, like if we'll take this part, right, or else I'll just write down the value so that you can work on this completely. It's 2 into 4 into 8 into 16 divided by its 2 square into its 3 cube by 2 cube into 4 raised to 4 by 3 raised to 4. Right, so here if we'll take, it's 2 available here, then if we'll take this one, then 3 is available here, it's 4 raised to 4 here, and then this is 2, right. These two values will come to the numerator. So now it's 2 into 4 into 8 into 16 into 2 into 3 divided by the values available would be nothing but 4 raised to 4. Alright, 4 into 4 into 4 into 4, so that it will be easy for us to work on. 4 into 4, 16 is cancelled, then this 4 is cancelled, 2 into 2, 4 is cancelled, so it's nothing but 24. My value is supposed to be 24 here. Alright, let's move to the next one. So if y is a negative number, it's already given y is a negative number, you need to be slightly careful here. Y is a negative number such that 2 raised to y square log 5 to the base 3 is equal to 5 raised to log 3 to the base 2. Right, now here can I write this value, this complete part, as 2 raised to log 5 to the base 3 raised to y square, right, which is equal to its 5 raised to log 3 to the base 2. Now I'll shift this value towards this side, so I can say that, if you remember, I had given the formula a raised to log b is equal to b raised to log a. So I'll utilize this thing. So 5 raised to log 2 to the base 3 y square should be equal to 5 raised to log 3 to the base 2. Right, now if we equate both of them, I can say y square into log 2 to the base 3 is equal to log 3 to the base 2. Right, So here it's y square into 1 by log 3 to the base 2 should be equal to log 3 to the base 2. So I can say y square is supposed to be log 3 to the base 2 whole square. So y value should be nothing but, as given y is a negative value, so y is nothing but minus log 3 to the base 2. Right, so it can be written as it's minus, and that means minus 1 is the value here. Right, the power is nothing but minus 1 here. I can say the value is log 1 by 3 to the base 2. My answer is supposed to be nothing but A. Right, let's see the next one. The real root of the equation, here it's 2 raised to 6x plus, I can write this value as 2 square into 2 raised to 3x minus 21 is equal to 0. So let's keep 2 raised to 3x as a for the time being. So it's a square plus 4a minus 21 is equal to 0. Right, so the values are nothing but a will be minus 7 and 3. These two are the roots available here. Right, in other sense this should be equal to 2 raised to 3x. Right, so 2 raised to 3x is the value available here. Right, now here the value cannot be minus 7, right, because it's 2 raised to 3x is the value available here, so it cannot be minus 7 here, so it should be 3. So I can say it's 3 should be equal to 2 raised to 3x. Now just identify, if you'll remember the basic of log, as we have seen 10 square was nothing but 100, so I can represent this one as log 100 to the base 10 is equal to 2. Right, so according to this my condition would be, I can say 3x is supposed to be nothing but log 3 to the base 2. Right, so if this is my condition, I can say the value x is nothing but log 3 to the base 2 divided by 3. Right, so my answer is supposed to be again A. Right, it will be A here. Next one. Right, so here the important part is this thing. I should keep in mind that this value should be is a real number if and only if real number. That means this value should be greater than or equal to 0. So I can say log 4x minus x square by 3 to the base e should be greater than or equal to 0. Right, now if it's greater than or equal to 0, can I say that this value 4x minus x square by 3 should be greater than or equal to 1? Right, my size is supposed to be 1 or else greater than that, because presently the hour is 0, or else it should be more than that. That's a condition given. So here if we'll work on this, 4x minus x square should be greater than or equal to 3. If we'll further represent this one, I can say x square minus 4x plus 3 should be lesser than or equal to 0, and according to this I should get the roots as 1 and 3, and my curve will be like this, any value beyond this part, as the value of y should be lesser than 0. So I'm talking about any value on this part. So it should be between 1 and 3, both inclusive. My answer is supposed to be nothing but option C. Right, let's take the next one. Let x and y be the positive real numbers, so that log x plus y to the base 5 plus log x minus y to the base 5. So I can directly represent this one as log x plus y into x minus y to the base 5, which is nothing but log x square minus y square to the base 5, and this value is equal to 3. And similarly, it's given log y to the base 2 minus log x to the base 2 is equal to 1, right? So in other sense, I can also represent this one as log y by x to the base 2 is equal to 3, right? So here, if we'll take this part, sorry, 3 minus, sorry, it's not 3, is equal to 1 minus log 3 to the base 2, right? So I would say that it's log y by x to the base 2 should also be written as log 2 to the base 2 minus log 3 to the base 2, right? In other sense, that's nothing but log 2 by 3 to the base 2, which represents y by x, should be equal to 2 by 3. So now I have two informations available here. From this, if we'll see, can I say y square minus x square is supposed to be 5 cube or else 125, and y by 3, y by x is in the ratio of 2:3. If I'll go by the option also, we can find out that the values will be, y will be 10 and x will be nothing but 15. So the product is nothing but x into y should be nothing but 150, right? X into y will be 150. The best way to work on these, I know that this summation is equal to 3, so I can take the value as 3 and 0, or else I can take the value as 2 and 1, or else vice versa, but obviously they are the positive values, so I have these two possibilities and I'll check. So x plus y, according to this, x plus y is supposed to be nothing but 125, and x minus y is equal to 1. That means the value is here according to this. 2x is equal to 126, x value is 63, and y value is supposed to be 62. But 63 into 62 is not in our option, so this part is ruled out. Similarly, I'll take x plus y, so I'll take x plus y as 2 here. If I'll take x plus y as 2, that means the value is 5 square, 25, and x minus y is 1, which is equal to 5. That gives you x as 15 and y as 10. The product is 150, which is available there. So I can also utilize the options to work on these values. Sometimes they ask very easy questions also, so I can see it's going to, if p cube is equal to s6, similarly q raised to 4 is also s6, r raised to 5 is s 6. So why I'm writing in the terms of S6 or else S, because my base here is nothing but S. So can I say, so I'll convert PQR in terms of S. So I can say P will be nothing but S raised to 6 by 3 or else S square. Similarly, Q will be nothing but S raised to 6 by 4 or else S raised to 3 by 2, and R will be nothing but S raised to 6 by 5. Right? So now according to this, log S into P is S square, Q is S raised to 3 by 2, and this value S raised to 6 by 5. Right? That represents this complete figure is nothing but S raised to 2 plus 3 by 2 plus 6 by 5. So let's calculate this. If we'll take down the LCM is 6, so 12, sorry, it's 5, right? So here it's 10, so this part is 20, 15, 18, sorry, not 18, 12. So it's S raised to 47 by 10. Right? So it's basically log S raised to 47 by 10 to the base S, which will be equal to 47 by 10 itself. Right? Value is supposed to be 47 by 10. Right. Next one. We'll do one thing. We'll change the base as 100 here. So I can definitely write this value as log 2 to the base 100 minus log 4 to the base 100 plus log 5 to the base 100 minus log 10 to the base 100 plus log 20 to the base 100 minus log 25 to the base 100 plus log 50 to the base 100. So positives are nothing but the multiplication, negatives are nothing but the division. So I can say log, what are the values here? It's 2 into 5 into 20 into 50, and the negatives 4, 10, 25 to the base 100. Right, so let's try to calculate this part. 2 times, correct. So it's log 10 to the base 100. Right, so if it's log 10 to the base 100, this option is 1 by 2, not 12. So that will be equal to 1 by 2. My value is supposed to be 1 by 2 here. Next one, if x is a positive integer, positive quantity such that 2 raised to x is equal to 3 raised to log 2 to the base 5, then find out the value, then x is equal to, they have asked. It's an easy question, it's a direct formula based question. I can say 2 raised to x will represent 2 raised to log 3 to the base 5, In other sense, I can say x will be nothing equal to log 3 to the base 5, right? So log 3 to the base 5 is the value available here. Okay, but the problem is there is no option which will satisfy this condition here, right? So I can also do one thing. I can represent this one as log 5 to the base 5 plus log 3 to the base 5 minus log 5 to the base 5 can be written in this format. Here I can consider this one as 1 plus this is log 3 by 5 to the base 5. So my answer is supposed to be 1 plus log 3 by 5 to the base 5. So I have to utilize the options to work on this. Right. Okay. So now it's given that if log 81 to the base 12 is equal to p, then 3 into 4 minus p divided by 4 plus p is equal to. Okay, so let's try to convert this value first. It's given because see here, if you go through the options has the base as 2, 6, 4 and 6, so which are nothing but the factors of 12 itself. So we can try to utilize this thing. I'll try to reduce the value first. I can say this value can be written as log 3 raised to 4 to the base 12, which is further written as 4 times of log 3 to the base 12, which is equal to p. I can definitely represent the value as log 3 to the base 12 is equal to p by 4, and I'll try to insert the value here. Since I know p by 4, I can represent this part as 3 into 1 minus p by 4 divided by 1 plus p by 4. That will be fine. And p by 4 is nothing but log 3 to the base 12. So something but 3 times of 1 can be written as log 12 to the base 12 minus log 3 to the base 12 divided by log 12 to the base 12 plus log 3 to the base 12. So further I can write this one as 3 times of log since it's subtraction, so 12 by 4, that's saying but 12 by 3, that's log 4 to the base 12 divided by, here it's log 36 to the base 12, right? Can also be represented as, I can take the value as log 4 cube to the base 12 divided by log 36 to the base 12, which is nothing but log 64 to the base 12 divided by log 36 to the base 12. Now I can at least work on this. I can represent this one as log 64 to the base 36, which is nothing but log 8 square to the base 6 square, can be written as log 8 to the base 6. So the answer should be log 8 to the base 6. So these are the questions which are basically calculation based. So the good part with log is you should know the formulas. If you know the formulas, you can always work on the questions. Sometimes not, sometimes many times you can utilize your options to work on the values. That's all for today. Thanks for joining us.